My name is Arvid, and this is Fastbuild, a short introduction. Let's start with what is Fastbuild. Well, the name probably gave it away. It's a build system. Let's get into more detail. Fastbuild is, as the name already has said as well, it is focused on building fast. It uses parallel compilation and an optional object cache to speed up compilation times. It has Unity/blob builds to provide another built-in mechanism to speed up your build. It is cross-platform. It has great support for all major operating systems, obviously including Mac, Windows, Linux, both as a target and as a host. It can, aside from that, target all major consoles and all major used compilers on consoles like GCC Clang, MCC, Green Hills, CodeWarrior, NVCC for Qt and whatnot. It is distributed. Fastbuild has a separate worker process and a separate worker component which you can use to distribute compilation steps over the network to improve your compilation times. It is lightweight. Fastbuild is in just a single 600 kilobyte, completely self-contained executable with no external dependencies. Installation consists of basically copying that executable into your path, and then you're good. You can check that in with all your sources, for example, and have it always in your repository to use. It is simple and easy to use. Fastbuild employs a simple yet very powerful DSL to configure your builds. It's easy to pick up and to understand. Fastbuild has built-in Visual Studio and Xcode project generation. It can create projects for all the popular IDEs. I will go into the detail a little more later on. If it has powerful support for Visual Studio, so if you have an error in your Fastbuild build, you can click on that error and you jump to that location. It has the same behavior as if you were compiling in Visual Studio itself. It has built-in statistics. If you ever wondered if your build is slowed down by one specific translation unit, hands up. Nobody? 1, 2. There was a pretty famous blog post just a few weeks ago by Aris from Unity, and he found this undocumented compiler switch in MSCC to document and give out statistics which translation unit or what function was slowing down your build. Fastbuild has completely built-in support for giving you an HTML output of all your object files and your translation units, and how long they take to compile. It's a super easy and nice way to optimize the build times. Let's compare Fastbuild a little bit to one probably major and known build system, CMake. Compared to CMake, Fastbuild is no meta build system. It does not automatically generate build files for your other build tools, for like Make or Nmake or Jom or Ninja. Fastbuild builds itself. Fastbuild uses the Fastbuild executable itself to build. The Visual Studio and Xcode project generation is manual. As I said before, you can generate Xcode projects and Visual Studio projects, but you usually specify the commands to run, where to look for includes, and specify the included projects. This takes a little bit of work. However, it allows for very, very powerful project creation. It allows you to build with the same Visual Studio solution for all platforms at the same time. This is a screenshot from my Visual Studio configuration selector. I can build for Linux, Mac, Windows with different compilers at the very same time and get all the executables after the build is done without ever leaving Visual Studio. It allows you to use native Clang on Windows. It has no, like CMake, for example, has problems with using the non-Clang-CL version of Clang on Windows. You don't need to write some toolchain or resort to other hacks. You can just use Fastbuild and put in clang.exe, put the flags you would normally use on Linux, and you're good to go. It has built-in pre-compiled header support. Back to the why Fastbuild is called Fastbuild. It's fast. Therefore, it tries to have all the support for all the speed-up mechanisms you need. Fastbuild is written in highly optimized C++. It's on GitHub. The link is at the end of the talk. And it's easy to hack on. It's rather small compared to CMake, which is kind of a big beast. Let's get started and write a little bit of Fastbuild and see how the DSL looks like. You need a little bit of boilerplate to have all the setup for your compiler tools like cl.exe or link.exe for the MSVC toolchain, or Clang++ and LD for Clang/GCC toolchain. I'll assume that the setup's already done. You can find the complete setup in a GitHub repository at the end of my talk. Let's get started. First, we need to include the required compiler definitions, which in this case are in the config.bff file, and BFF is the usual suffix you would use for a file of Fastbuild. Next, we define an object list. Since we want to compile some sources, we need that, and object list is that function you're going to call for that. They're called functions, but in Fastbuild terminology, but they aren't really functions, so think of them more like as a definition of a target. In that case, we will just glob over the input path, get all files with the ending of .cpp, and compile the object files to _out. Next, we need to link our executable in place. For that, we use the executable function, and we link our just defined object list, and then put the linker output, the exe, into _bin/hello world.exe. Last but not least, we define an alias called all. All is a predefined alias, so if you invoke fastbuild on the command line, you just say fbuild, and it builds what you defined as a target in your alias all. That is basically all you need to build the very basics of a Fastbuild project. You can find that example for the MSVC toolchain on the GitHub at the end of the talk. That only requires you to open the repository, clone it, and then open it in a MSVC command prompt, so you have your cl.exe and link.exe in your path. And last but not least, I just want to go quickly over a few tips and tricks, because Fastbuild has a non-Turing complete DSL, which might not sound very powerful, but it is actually very powerful and easy to use, and does not make you, or kind of prevents you from writing an actual program in your build system like you sometimes do in CMake. You don't have branching, you don't have an if. You compose variables dynamically by specifying the name of the variable and then composing that variable. You can import environment variables, so that's what I do, for example, in the MSVC example. I import the MSVC environment variables to find the path to your Visual Studio installation and where cl.exe is located. It has structs, like you would expect, but those structs uses scoping. So if you define foo in the struct A with value 1, and then you define another struct B, you would use the using directive to get all the values of struct A into the scope of struct B, and then you can extend that struct A, for example, in that case, with bar and setting to value 2. Let's go quickly through a little more bigger example, like what I do in that screenshot you've seen from my Visual Studio. That is using configs. So I create all the configs for different compilers, for different architectures, and for the different operating systems. As you've seen here for the x86 and x64 example. And then we basically have a for each loop over all the configs. Use that just described using directive to get the config into scope. Fastbuild will then automatically use all the predefined variables, like .compiler in that example, use that in the library function, and compile our libraries for x86 and x64 at the very same time. And here you'll find the Fastbuild website, and you'll find the minimal example at that GitHub link. I will push that in a few minutes. If you want to have a more fully featured example, or template rather, go to the link from Pirik Pavel. It's a very nice repository showing you how to set up a full complete tool chain with Fastbuild. And if you have any questions, I'll be here, and you can. Oops, and you can find me. Thank you very much.